All right, day 5 of Advent of Code. Okay, page ordering rules, 1 per line. Which updates are already in the right order? Pages to produce in each update. Okay, sorry, I gotta read this more carefully. If an update includes both of these numbers, then, okay, so this is a constraint that this is less than this. Oh, I see, some of these are ordered. Okay, this is gonna be like, some sort of DFS type counting. A needs to come before B, right? Let's make a graph. How do I actually want to do this? If it's in the right order, okay, fine. Let's just do, I just need to get writing something. So what we'll do, and then for all the adjacencies of X, we are going to recurse on the adjacencies. Okay, start with, so for I think this seems fine for now. What? Oh, shoot. I forgot about this. I was playing around earlier. Okay. So what does this look like? Got a bunch of numbers, and the question is now, are they in sorted order? Is this really sufficient? I feel like I did something. I feel like this is not right. Maybe it's better just to check to see if any rules are violated. How many rules are there? That's a lot of rules. Wait, yeah, I should just be checking if any rules are violated. Oh, crap. I wasted a lot of time there. Okay, and then for each of these, what we're going to do is if and what did I do wrong? Oh, whoops. It's index, not find for list. That's sad that I messed that up. 84? Oh, sorry, it's asking something else. What do you get if you add the middle from the correctly ordered pages? The middle page number, the middle. I don't know which way it rounds, but maybe they're all odd. Okay, so in this case, is that right? That is right, I think. Okay, rank 309. Oh, that was slow. For each of the incorrectly ordered pages, use the page ordering rule to put the pages in the right order. Okay, maybe now I want my DFS back. Taking only the incorrectly ordered updates and ordering correctly. Shoot, I got rid of the thing I cared about here. After correctly ordering just those updates. Okay. So if we're not, then X, and then now I think it's this. No, it's not that. I'm really unsure about my connected components algorithm. Oh, or sorry, not connected components, my like numbering. Yeah, this is definitely wrong. Shoot. Maybe, oh, I should find the root. The root is going to be the only thing that does not appear anywhere else. So let's do the root. Finding. Is that going to be sufficient? Yeah, shoot, no, this is just not going to work. I want like the post order number. I definitely, shoot, how do I actually want to do this? I'm not sure. Is there like a dumb, easy way to do this? I'm so rusty. The fact that I can't figure out the best way to do this. I can try and write this, the root finding. No, the root finding thing is not going to work. Okay, what do I actually want to do? I want to make sure that we get numbered with a higher number than all of our children. So let's do this. So in this case, we'll do just to add it, and then okay. Now what I think we'll do, does this work now? I think whatever that was doing is wrong, but let's look at this. So now I think well, clearly something's not working. This is... Why is this the same answer? That feels very suspicious. This feels like I have a deeper bug. Okay, well. Let's just look at a rule for starters. See if this works. 26 is a lower number. Yeah, I already submitted 5725, right? Oh, I guess reversing the order doesn't change the middle number, so. I guess this is one way to see if my algorithm is working. I suspect it's not. Yeah, it is not working. Shoot. Oh. Wait, yeah. Well, what I want here is a topological sort. And I just clearly did not accomplish such a thing. I thought... this is still going to be a DFS, so I think, yeah. This feels like effectively the same thing that I've written here. Is it different in a way that I'm not materially understanding? How is that possible? Oh, I see. Wait. What? Yeah, no. How are we hitting a page that's not seen? I guess... Oh, sorry. Now it's, Oh, I want ordering, not C. No, I'm still doing something wrong. I'm really rusty. I need to do some more algorithms practice or something. Because today and yesterday I've not been going so well. X and G. Okay. Interesting. Okay, and ordering dot index 69. That's at index 48. So it needs to come before all of its children, which is at 47. I might need to reverse it, but that doesn't seem like an issue. I mean, one of these should have still been correct, so I'm a little confused. We should figure out why it's not ordered here. Oops. So what we'll do is okay, so the rule that is being violated in the initial one is this one, which is fine. When we sort, this is the rule that's being violated. So there's a rule that 66 must come before 92, and in our ordering, '66 appears after 92. How is that possible? Did I like set up my dependencies in the wrong order? I feel like no, I feel like it shouldn't matter. Can I just not write a topological sort? That also seems unlikely. Every page should appear. It should be one of the earlier-ish rules. It's rule 24. We visit everything from the first X. shouldn't be any cycles. What's going on here? Okay, the rule that's being broken. 86 must be less than. This is just turning into a debugging session, I guess. So I'll explain a little more of my thought process here. So page 86 must appear before page 56. And like, that is an explicit rule. When we traverse, let's add this, traversing, maybe I should do if. Okay, so it hits 86, and then okay, traverse 86. There were rules that, oh shoot, maybe I only want to print this out if we are there, seeing it for the first time. Okay, so when we traverse 86, where does 56 appear? 56, is the problem that we already visited 56? I thought 86 needs to come before 56. But also 56 needs to come before 78, which needs to come before eventually 86. That's a little confusing. That is very confusing, actually. We have a lot of rules for the number of numbers that we have, but it doesn't really matter that much. I'm going to copy this out somewhere else, and then I'll just sanity check. Entirely possible I did something buggy here. Let me make this so I can actually fit it all on one screen. Okay, so what am I doing? My rules are set up so that, yeah, this didn't change the rules, right? No, did not change the rules. Yep, okay. I just want to double check that. If it includes, oh shoot, how did I, oh, it's only if the update includes both page numbers. That explains why there's so many rules. Shoot, okay. That's kind of ugly. Like, is the proper way to do a topological sort for each rule? It just feels awkward. Well, I guess I'll write the most proper way then. So to get an ordering for some update, first we need to figure out which rules are applicable. I'm only like half writing this clean code because I don't want to go rename all my variables. I guess I don't even need this. I can just put my graph here. And then what we'll do, I don't need that anymore. I'll just write like this is not very efficient, but it's fine. Just kidding. I need this instead. Okay, I mean, I don't even need this then. Now it just needs to be, yeah, and then it's just the ordering. Oh, sorry, I got the call topo and everything, but that's easy enough. And then it's just this. That's a number. That is still not the right answer. Well, shoot. Oh, whoops. Only if it was unordered. Grab this. And then oh, come on. There's my answer. 31 seconds. Oh man, rough couple days. Let me get rid of the print. Oh man. I wonder if there's a hackier way that did not involve like a topological sort to do this. I guess I'll find out when I see how many people have already solved this part. Okay, about 2,000, which is not a huge amount. So maybe topological sort is what you should do here. I'm not entirely sure. Oh man, 2 days in a row of the part 2 just like going so awfully for me. Yeah, I think I'm definitely a lot rustier than I was in previous years. It's just been a while since I've done a lot of like algorithmic coding. I feel like this problem will only get worse as we get into the later days where I actually need to think a lot harder. Man. But yeah, I guess I'll take a second maybe to explain what I did. I feel like I explained it reasonably well. Yeah, I'll give them a bunch of rules that say if both of these, no, so these are page numbers. If both pages appear in a sequence, then the first page needs to come before the second numbered page. And it basically just asks you to do some operation after ordering all of these updates. I'm like glossing over the details that are not that important. The gist of it is like, how do you actually resort these? First part was just figure out which ones are unsorted. And that's not too hard. You just like check each rule individually and see if it's being broken. For part 2, where you have to actually do the correct ordering, the thing that I did, and I'm still not convinced that there's not a like dumber solution with like a much higher time complexity, but the thing that I did is for a given sequence, I filter down to which rules are applicable, and then I do a topological sort. So I like construct a graph from the applicable rules, and then I traverse it in a specific order that guarantees it will be ordered. I think explaining a topological sort in its entirety is probably out of the scope of this video, but roughly what I'm doing here is just a depth first search, and when you reach a node in the graph, the first thing you do is you mark it so that you don't like revisit it, and then you traverse all your all your child nodes, and once you are done with that, it is guaranteed that everything you have visited, everything that should appear after you, either should appear immediately after you because it's child, or should appear like after the thing after you. All of those will guaranteed be visited because of like it's just how a depth first search works. So at that point, we know that we can safely add the current thing to our ordering. And then at the end, you need to reverse the ordering. I didn't actually reverse the ordering here because it doesn't matter, because all we care about is the middle elements, but for sake of completeness, I could do like ordering.reverse after calling all the topo sorts. But yeah, that's basically the gist of how topological sort works. And when you do this, you have to start at every possible node because you could have like disconnected components in some sense. So it's important to like make sure you visit every single node, even if they're not disconnected. If you like happen to start at the child. Cool. Yeah. Well, anyways, that is day 5 of Advent of Code. I might need to spend a little bit of time brushing up on my algorithms and speed coding in general, because this year has not been going so well for me so far. But yeah, other than that, I will see you tomorrow.